Today's video is going to be on a series of different problems that all involve the same type of math and sort of the same type of mathematical thinking. So we're going to look at these type of problems. Something like this right here. Question's going to be, what portion of this shape is shaded? And we might look at something like this one right here. Maybe I'll give you a circle, give you a square in the center of it, an inscribed square. And I'll ask you for what portion of this shape is shaded. In this case, we have a square inscribed in a circle. And then finally, we'll close it off with the opposite. I'll give you a square with an inscribed circle. And I'll ask you to find out what portion of this shape is shaded. Now, these all involve the same math. They look very different. Especially these two look very different than this one right here, but they all involve the same math. And before we actually look at the problems, I just want to go over the basic idea of what we're going to be doing. Okay, this problem here, again, core math. I want to find out what portion of this is shaded. What I'm going to need to know is the area of the square minus the area of the circle, and that will get me this portion that's outside these realms. Well, let's say this had a, let's do 4 again, make our lives easier. So this is 4. Well, if I'm thinking about the rectangle, wouldn't that just be this is 4 and this is 4, so this would have a combined area. 4 times 4 is 16. Because we're doing length times width for the rectangle. And my circle, well, that's pi r squared. So wouldn't that be pi times the radius squared? Well, we just did this before. Pi times 16 got us 50. Oh, I'm sorry, I made a mistake here. This should have been, this is 4 and this is 4, so the measurements here are 8 by 8. Oopsies. It's good, you know, this is really good. This is a good example of, as you go through the problems, you notice mistakes that you make because something doesn't add up and you have to make the correction. So I noticed that my circle here has an area of 50, and I knew that the square has got to be more than the circle. So I went back and I checked and I realized, hey, I only used a small portion of the measurement, so I didn't actually have the exact measurements for the length and the width. It should be 8 by 8, which would give me 64. So the difference is 14, and I subtract the 2. Now the question is, what portion of the entire shape is shaded? Well, this is 14 over 64. Look, there's no real easy way to do this. I might lean in one way, I might say it's this or that, but you know, you could always take out your calculator. And you could do these core problems very quickly. So let's just say I wanted to make sure I have the exact amounts here. So let's see, where's my handy trusty calculator on this wonderful device here? There's a calculator. Let's open it up. Where does it pop up? Alright. I have 14. What's 14 divided by 64? 64. It's about 22%. Why did I do the calculator? Well, you know what? I'm really tempted to round this to 15 and 60 and say it's about 25%. But it's actually closest to 20%. So I want you to just remember that outside area is approximately equal to 20%. That's what it's closest to. Obviously, you could go into more detail on this, but these are a couple different ways of dealing with those type of problems. So just to review, we looked at these 3 different problems. We looked at same question: what portion of the entire shape is shaded? You found out for this one, 1/2 or 50%. What portion of the entire shape is shaded? And the portion here was that outer region. For this one, again, to find out that outer region, you found out the area of the hole minus the area that you could figure out, and that helped you figure out that portion that's shaded. And then we had that, and this is an example of an inscribed square. And then finally we had this question of a square, and inside the square we have an inscribed circle. And again, I used the same type of math. I took my hole, which is the square, I minus the circle, and we were able to figure out that portion of the square that's left over. And if we did this right, this was 50% here, this was 36% approximately that was left shaded, and this portion here was approximately 20%. Okay team, I hope you found these videos helpful. Again, you got to review your core math. Your core math always is going to be extremely helpful. Length times width for a rectangle. If it's triangle, it is length times width, or even better, base times height. And we're going to do 1/2 base times the height, because that's always going to be half the area of a rectangle. And then for a circle, you got to remember this for the area of a circle. And you know the radius. The area of that circle is pi r squared. And pi is always going to be, usually is approximated at 3.14. So whatever 3.14 is times the radius, whatever that is, squared. Okay team, I hope you found these videos helpful. For this one, I'm dividing into 2 sections. So there's a part 1 and this is part 2. Thank you. Have a great day. Bye-bye.